Hello, our presentation has to do with discrete distributions. This will be going into the Michigan Chemical Process Dynamics and Controls Open Textbook online. The authors are Chris and Angela. The overview goes as follows. What are discrete distributions? And from what are discrete distributions, we will be obtaining the different types of distributions, and they start off as binomial, Poisson, and hypergeometric distributions. And from there, we'll be showing you the summary of key equations for each distribution so that you can use them in the everyday applications shown at the end. What are discrete distributions? The most important thing in a discrete distribution is the random variables. Each outcome is randomly determined, and for example, flipping a coin has heads or tails as a result. The most important thing in a discrete distribution is the sum of the individual occurrences. Representing random variables as a function of probabilities are discrete distributions. That is the basic definition of what a discrete distribution is. They are also called a probability mass functions. The probability of a specific random variable equaling a discrete value can be described by a discrete distribution. The first basic distribution that we'll be talking about is binomial distribution. The two necessary conditions for use are only two outcomes are possible, and the sampling must be random. You can use this distribution function to predict the probability of a desired result. The area under the distribution curve always sums to 1. The equation shown below is used for this binomial distribution.
The next distribution that we'll be talking about is the Poisson distribution. This is a specialized version of the binomial distribution. It's most used in situations where the total number of successes are known, but the number of trials are not. It can be used to approximate the binomial distribution when n is large and p is small, where n is the total number of possibilities, and p is the probability between 0 and 1. The equation for the Poisson distribution can be seen below. The last type of distribution we'll be talking about is the hypergeometric distribution. To use this distribution, there are 3 necessary conditions. Only 2 outcomes are possible, the sample must be random, and selections are not replaced. In other distributions, the number of possibilities remains constant, but in a hypergeometric distribution, selections are not replaced, which means the number of possible selections decreases. For example, in a selecting red and green balls from a small container, once a ball has been selected, it is not put back in the jar. The equation for the hypergeometric distribution can be seen below. On this diagram, this is the summary of distributions. It shows all the 3 distributions we discussed, including the requirements for use and the distribution functions. Note for the hypergeometric distribution that the equation in the table is a shorthand version of the one seen on the previous slide. For everyday applications, these distributions can be used to calculate your grades in a curved class, figure out likely concentrations, or to determine the probability that a clown will make a certain balloon animal for you.
I see dead clowns, 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 clowns. They're so fun and happy all the time. Happy clowns.